This is a quick video to show you how to approach going through a basic kinematics problem. So this problem, at t equals 0, a car has a speed of 30 meters per second. So I can make, I'm working on my diagram for A. I'm going to draw a car. And I'm going to draw an arrow showing it's going at 30 meters per second. After 6 seconds, speed is 15 meters per second. So I'm going to draw the car again. Sometime later on, I'm going to draw a shorter arrow because it's going less fast, and that's 15 meters per second. I'm going to assume that they're both in the positive direction because there's no reason to think otherwise necessarily. And I'm going to say that those are 6 seconds apart. I have a pretty well labeled diagram. What I want to do is label these with variables if I know what they are. So at time 0, the speed was 30, so that's v0. There's another velocity, so that's v. And seconds, I think that's going to be a time. So I have my well-labeled diagram. Check. A well-labeled graphical representation of this would show I've got 15 meters per second, 30 meters per second, and 1, 2, 3, 4, 5, 6 seconds. And I can draw a line connecting those 2 points. You know, ideally it's a straight line, but this is fine. So I got that. All right, now I can start approaching my problem. So first off, I want to list the given quantity. So I always write this out the same way. So I write out the starting position, ending position, starting velocity, ending velocity, acceleration, and time. And it helps if you can write them out in roughly the same order every time, just for your brain. Keep things in. And now I'm going to start plugging in information that I know. So I know that the starting velocity is 30 meters per second. I know the ending velocity is 15 meters per second. I know the time is 6 seconds. And I also can infer, based on no other position information, that my starting position can be 0 meters. It also wants to know how far does the car travel, so it really wants to know a displacement. If I make my initial position 0, then my final position will be the displacement. From here, I want to find out 2 things: the average acceleration of the car and how far does the car travel in this time. So first off, I have 3 equations that I can work with. So let's start with the first one. So we got x is 1/2 at squared plus v0 times t plus x0. And on first glance, I might not know if I have enough information to solve that. And that's why I use this trick. So I can go through, I can underline anything that I don't know the value for, like I don't have a value for x. So that is an unknown. I can underline it. I can also underline a, but I do know t. I know v0, I know t, and I have put something in for the initial position. So since I don't know 2 different values in this formula, I can't use it yet. I would have to know one or the other in order to solve it. So I might go to another formula. So how about, let's just go back to black. V equals at plus starting velocity. And going through this one, look, I know v, I don't know a. I know t, I know v0, so I can solve this formula, which is great. So now I'm going to very carefully make sure that I plug everything into the right spot. So I can plug in v is 15. A, I don't know, I can just leave it as a. I know this is 6. And I know the starting velocity is 30. Now I can solve. So minus 30 from both sides. That's minus 15. A times 6 divided by 6 divided by 6. 15 divided by 6 is 2.5. So A is negative 2.5 meters per second. And that makes sense because I have a negative slope on my graph over here. That's great. And I can even double check that. I can say, okay, so the slope is negative, and negative 2.5 makes sense because it goes down 15 in 6 seconds. And then it better match up because remember that equation that we just used came from this graph. All right. Now that I know that this is negative 2.5 meters per second, then I can go back and now I should be able to solve the big formula up here. And the only quantity I have left. So x equals 1/2 negative 2.5 times 6 squared. It's just the 6 that's squared, guys. Just make sure that you pay attention to that. Plus v0 is 30 times 6 plus 0. All right, yeah, I have everything plugged in. I should just be able to solve. So 1.25, negative 1.25 times 36. So that's half of negative 2.5 and 6 squared. Plus 30 times 6 is 180. So this is negative 1.25 times 36 is negative 45 plus 180 is 135 meters. And that is how far I think the car has gone. So I have these two pieces of information. I double checked this. Now I want to double check my displacement, my final position. So I can go in to this graph and remember the area under the velocity graph is the displacement. So this area I can define as two shapes. Now if you look at kind of the bigger picture here, this whole thing is a trapezoid, but I don't remember how to find the area of a trapezoid, and I'm guessing neither do you, but a triangle and a rectangle should be doable. So the first one is 15 meters per second tall times 6 seconds wide, and that comes out to 90 meters. And then this top triangle shape is a half of the base, so a half of 6 times, if you look at this, this is between 30 and 15, is also 15 tall. And so half of 6 is 3 times 15 is 45 meters. So 45 meters plus 90 is 135 meters. So that is the same as what I got over here. So that checks out. And that's my whole problem. It's very easy to mess stuff up, which is why I'm going to really encourage you to check. In particular, in this problem, the first time I tried to do this, I swapped those two velocities and I got numbers that did not match up at all. So always be sure to double check what you're doing. All right, good luck.